Like I said, today we're going to talk more about pairing Fronius inverters with APSmart. So Fronius Symo Advanced inverters and the APSmart rapid shutdown disconnects are pairings that we carry those products here. We're excited to learn more about them. And just a reminder to put any questions that you have in Q&A, and we'll address those at the end. And I will, with that, kick it over to Braulio to get us started.
Hello, everyone. I am going to present right now. Thanks, everybody, for joining. So thank you very much for the introduction, Kate. We're very appreciative for everything that BayWa does for us. You guys have proven yourselves every year to be great partners to us. And we're very excited for what this year is going to bring to us. So this webinar is aimed towards instructing you guys on how to overcome complexities in commercial solar and how a careful inverter choice can optimize the project while complying to the latest code standards. In this presentation, I have Yi Kang from APSmart. He's going to help me uncover some of the features of the Symo Advanced, most specifically into complying with the latest rapid shutdown requirements. But I'll also be diving further into shade mitigation. I'll be talking about how the Snap inverter line, or more specifically the Symo Advanced, is field serviceable, so that ultimately your commercial PV systems are easy to design, install, and maintain. So without further ado, my name is Braulio Escobar. I am the regional sales manager here at Fronius. Most recently, I've been fortunate to work with BayWa in the Midwest and other select regions in the US. This last year, as many of you know, has been a little bit trying for all of us. But on my side, I've been very proactive, been trying to work with solar contractors all over the US, trying to understand their business needs, and with understanding what their needs are, I've been able to tailor my knowledge and solutions to best tackle them. What you see in the back of my picture is our vision of 24 hours of sun, which is a vision of a world in which we cover 100% of our energy needs using renewable sources. To that point, I just want to add that we envision to do this while taking safety as #1 priority. Actively, I'm trying to look for business that align with our vision to achieve it. And if you're new to Fronius in this presentation, well, I'm hoping that this presentation brings value to you, but we're a leader in solar, as well as battery charging and welding technology. Actually, 2021 marks our 76th year anniversary. And as a company that is well-versed in the controlling and monitoring of arcs, we've noticed that the field of PV safety is a challenging topic in the United States. So we've been dedicating a lot of efforts for the betterment of it. So in this presentation, I'll be talking about some of our findings, which I hope that proves valuable to when you're talking to your clients. We have a pretty packed agenda today. I'm going to start talking about the challenges that we can find in the C&I segment, following by talking about the Symo Advanced. I'm going to pass on the mic to Yi Kang afterwards, and he can talk about his rapid shutdown solution. Then my last topic will be comparing string inverters versus MLP in the commercial market. And we're going to have probably 10 to 15 minutes to address any questions or remarks from the audience. So let's do this. One of the major markets that we hear often is that no rooftop is the same. We've learned that the numbers of roofs that are easy to install, and by those I mean those that are very flat, very simple to install solar, are actually decreasing in numbers. So this will leave installers with the challenge of installing those complex roofs that are very choppy or just have a lot of obstructions. This is an example of what you can see on the roof. So commercial rooftops are pretty complex, usually coming with multiple architectural obstructions, and that impacts the design and the cost of the solar installation. So examples can be HVAC units, it can be chimneys, setbacks, or pathways that are only a few obstructions that designers and installers have to deal with. And some other thing could be, another challenge could be like the roof size, the shape of it, the supporting structure, and even the finish of the material can vary greatly. And so in some cases that can also affect the number of penetrations. So this can make it very difficult to create large array blocks. So in cases like that, smaller inverters make a lot more sense over having PV circuits crisscrossing the roof from array to array to meet the desired DC ratio of the inverters. Another challenge that we're seeing is that mounting inverters on the rooftop are another big consideration, because these are going through, being on the roof implies that the inverters are going through very harsh roof environments. So in places like the Midwest, in the winter, it can get absolutely cold with the polar vortexes. You might see that temperatures get to drop all the way to -30 or even below. And then other places like Arizona or like Southern California, Texas, it can get really, really hot in the summer. So temperatures can go up to 140 degrees and more. By their nature, flat rooftops on commercial buildings are pretty harsh, whether it's for summers and winters. But while it is commonly known that higher temperatures have an impact on the efficiency of the solar modules, the impact on the inverters is oftentimes overlooked. So even in temperate climates, commercial rooftops can quickly reach temperatures of, like I said, 140 degrees. Power electronics in the inverter automatically derate as protective measure when temperatures are too high or too low in some cases, affecting the overall system yield. So yep. And then a third challenge is that the rapid evolution of NEC rules and regulations have caused a mandatory adaptation of solar technology as a whole. Specifically, the requirements for module level shutdown can be challenging for solar installs, and that's going to be one of the main topics of this presentation. Another challenge is with B2B customers, customers that are very focused on having extremely high performance expectations. Because at the end of the day, when they're investing in the PV system, they're only thinking on ROI. They're not really thinking about the brand. They're not really thinking about saving the environment just as much as it is for them to have a positive return on investment. So reliable and safe operation it's demanded. It's something that it's indispensable for them. So without further ado, I'm gonna throw out some polls throughout the presentation. This is gonna be the first one. So my question for the audience is, what is your main consideration when choosing an inverter in commercial systems? The first answer is reliability. Second one is good tech support, monitoring, ease of installation, or compliance to the latest code standards. I'm gonna give it a few seconds, maybe 30, 40 seconds. Okay, I'm gonna end polling. So let me see if I can share this with you. So majority of the people has said that reliability is the main consideration. I'm sharing the results with you. As I said before, the vast majority said reliability, and I don't think it's a far-fetched assumption. Reliability is probably the most important thing, especially when I'm guessing that you're face-to-face with B2B customers. They're only really thinking about making sure that the inverter is reliable. And at the end of the day, inverters are in commercial systems are, in commercial systems, reliability is definitely one of the biggest considerations. Someone said that complies to the latest code standards is very important. I agree with that. I think that it's something that we cannot overlook, but it's definitely a challenge. I hope this presentation proves valuable to you. To make systems successful in the long term, we at Fronius have taken principles of energy supply into account, and that's why we have designed our snap inverters the way that they're designed. When I talk about optimization, I don't really mean like module level optimization, but more like achieving a cost-efficient solution when meeting the performance expectations and other customer needs. A system that can adapt to the future creates optimization at the project level, So if you optimize the entire system, you will be able to achieve the lowest cost of energy and achieve the highest return on investment. Adaptive system design also allows for future upselling, making today's investment future-proof. And then minimizing the amount of components in the system allows for higher reliability as well. So the less components, the system will be less prone for failure. So all these together add up to our vision of 24 hours of sun. So without further ado, by taking these principles into account, we've come up with the Symo Advanced. So let me show you how our Symo Advanced solves the challenges that I mentioned earlier by providing solutions based on our principles. We also have Yi Kang in the presentation today, and he will be emphasizing on the module level shutdown requirements for commercial systems. So the Fronius Symo Advanced combines the benefits of the Fronius Symo with the convenience of an open industry standard. The only exception to it is the Symo 15, because it's not part of the advanced version, but we still see a lot of demand for it because of its power class and because of this operating voltage. The Symo Advanced operates from 10 to 24 kW. It's a niche market that we've been able to address pretty well. It's used for the 208 and 240. I've seen them very, very popular in agriculture applications and small commercial buildings. And then there's also a niche market in the 480 volt market where the larger inverters just don't happen to address the same way that we do. So as I was saying before, we've seen that niche market that's very popular in 208, 240. Three-phase. So I've seen farms where the water pumps are old machinery that just work at 240 three-phase. Commercial buildings are very popular for having 208 volt. That can also mean schools and other office buildings. And because we have this designated inverter class that has this voltage specification, the best saving of all is that you don't need a transformer for these installations. That means that you're reducing balance of system costs. The installation is going to be a lot more easy. And because there's no transformer on site, there's no power loss. So the efficiency of the system is going to be a lot higher. So these in the fields of flexibility, we talked about how our inverters, the power classes add up for giving you the flexibilities that larger inverters don't have. So let me tell you how this inverter can help you overcome these challenges in small and medium commercial systems. So the range of power classes and electrical service types speaks to the potential challenges that we were talking about. So instead of running high voltage DC conduit across the rooftop to connect parts of both arrays, the electrical arrays can be the same as the physical arrays. So with a 15 kW and a 24 kW Symo Advanced, you compare these two together and achieve the same objective. Whereas if you're using only one inverter, you must run DC conduit to connect two separate areas. Also, if greater granularity of monitoring is desired, having two inverters gives you 4 MPPT channels to monitor instead of 2 or 3 MPP channels. If the building owner wants roof area A to service one tenant's electrical meter and area B to service another's, it's simple with 2 inverters. In fact, the 2 tenants might even have different voltage services. Let's say, in building A, there's the 240 delta, and on B, there's a 208 delta. PV array dimensioning is pretty flexible and easy. Our inverters offer a wide voltage range that goes from 200 to 1,000 volts with 2 MPP trackers and allowing for oversizing of up to 150%. If you're relatively new to string inverters, we have a string configuration tool that makes it very, very easy to design with our inverters. A new feature that I learned about is that even as the module sizes are increasing every year, and let's say our software team is not able to upload the newest data sheets on the website, if you have your login, you're able to add the new module model, and it's going to be saved into your profile. So that way, the design is going to be a lot faster because everything is saved up. So having a NEMA 4X rating on our inverters and an optional shade cover provides you with a lot of options in installation on a rooftop. So our inverters are pretty light. They weigh less than 100 pounds, means that it is easily handled by a couple of people. And these units do not separate they don't have a separate DC disconnect or a wiring box. And they have integrated fusing, and in some models for individual string overcurrent protection instead of additional fused pass-through transition boxes or inline fusing equipment. So this easy installation leads to labor savings for your business. So you have fast installation that reduces the cost of installation, and simple connection reduces your error rate so that it is less likely that you have to return to the site for fixes after the installation. And the best part is once you know how to install one, you know them all, because the Fronius Snap inverters from 3.8 to 15 kW single phase and 10 to 24 kW three phase have all the same look, the same architecture. They all have the same feel. It's a very replicable installation process. So this saves you from training, your installation crews if they're new, or they're doing both residential and commercial. So that makes installations a lot more consistent across the board. So that would help you eliminate some potential errors on the job site. I was talking about earlier on my previous presentation about a shade cover. So to improve the reliability in extreme weather conditions on the roof, the Fronius shade cover can help. This is how this is a visual representation of how it looks. As you can see, it sits on top of the inverter, which leaves about a 4-inch gap between the cover and the inverter for the cool air intake to remain functional. And there's also a gap at the top, allowing the heat exhaust to escape. The menu buttons and the LCD screen are still fully accessible for production viewing, for programming and settings manipulation. Okay, so in the fields of reliability and safety, I think, or I am very confident that there's second to none of what Fronius can do. So in this challenge, I think I would like to show you how we can overcome the challenges in reliability and safety. But first of all, to ensure a reliable system, you want to make sure that you have a good monitoring solution. And our solution is pretty inexpensive because a couple $100 and an internet connection, whether it's Ethernet, so plug in the inverter with a Cat5 cable or using Wi-Fi, or even in some cases when the job site is pretty remote, you can get a cellular option, which will get the yield and status code data to our free monitoring platform, which is SolarWeb. With one single data logger, you can connect up to 99 inverters, or you could do 2 data loggers and have 50 on each of them. To get data to our monitoring platform, you will need a data logger, which is what we call the data manager. You likely may only need one of them, as I said before, and all the information that goes from the inverter is sent to this one card via whatever internet source you have. And from there, you can view it from your laptop or also via smartphone, because we have an app for it. And so it also supports iOS and Android. We also have an option for cellular. So if you need more information for this option, just reach out to us, and you can follow up with me at the end of this presentation. So what about module level shutdown? How can I comply with this code requirement, and how can I find a good solution? I want to throw the ball actually to you one more time. I have another question for you. So what is your biggest concern as an installer regarding module level shutdown? So 4 options. that module level rapid shutdown actually works when it's triggered, that no arcs can be recognized by the inverter due to nuisance, increased points of connections lead to more product failures, or you're not sure. So here are the results. The vast majority said that increased points of connection lead to more product failures. Some people said that they're not sure. Well, hopefully, as if you continue to tune into this presentation, you're going to be able to learn a little bit more. And that module level rapid shutdown actually works when it is triggered. This is pretty consistent with someone being concerned for reliability in commercial systems. So I'm glad that you were able to address that. But increased points connection lead to more product failures. It's definitely a numbers game. But I'm going to leave that to Yi Kang so he can present his solution. There's definitely thought being put into that. But thank you very much for your answers. So let's look at the criteria for good module level shutdown. Everybody here knows that safety is the top priority. In assessing module level shutdown solutions for safety, it is crucial that the switching mechanism is safe and reliable. So it works when it is actually needed because lives depend on it. This means that making sure it can perform reliably in all situations and extreme temperature conditions. Additionally, shutdown devices must not create any type of noise that could interfere with AFCL algorithms and thus put in the inverter to the risk of doing nuisance stripping or not detecting arcs or real arcs, if you will, or interfering with and causing the shutdown function to fail. Last but not least, additional points of connections should be avoided to reduce arc risk. And once the safety criteria is met, the cost and the operational reliability can be taken into account as well. So if the safety portion is addressed, the economic portion is also taken care of too. So in order to push for the safest, most reliable, and economically feasible solution, we let the nature of a competitive market take its course. So having an ecosystem of products, services, and information systems that work well together, that cost less to build and operate, and interoperate wherever they are deployed, we're going to be achieving a higher adoption of the solar energy, which bring us closest to a world that does not rely on carbon-based energy sources. So without further ado, let me present to you the Sunspec Alliance. So the Sunspec Alliance is composed of more than 100 solar and storage energy industry participants. And the overall objective or the mission of the Sunspec Alliance is to accelerate the growth of the industry and to expand the market for renewable power by specifying a set of standards. And for the scope of this presentation, standardized communication protocol between PV system components that enable solar PV and energy storage distributed energy power plants to interoperate transparently. The Sunspec communication standards enable scaled efficiency. It's very plug-and-play interoperability, and this allows for long-term operational continuity for industry players across the board. It's fairly simple how it works, actually. As modules and inverters are connected via DC wires, the power line communication can easily be utilized in the solar system. So if modules have a Sunspec receiver and the inverter has a Sunspec transmitter, then they can communicate with each other. The receiver provides a standby signal and the transmitter sends a permission signal. So if AC power or the inverter is being turned off, the permission to operate signal goes away and the receiver at or in the module shuts the module off. It's as simple as that. It's very plug and play. So one example of a Sunspec shutdown device is the APSmart rapid shutdown device. And this solution is PVRSS certified with the Fronius Symo Advanced and works well based on the Sunspec rapid shutdown industry standard. So I'm gonna pass on the mic to Yi Kang, and he's gonna be able to dive a lot further into APSmart, what they're all about and what they have to offer. So Yi, welcome to the presentation. Yes, I can hear well.
Right. Thank you, Vera. Hello, everyone. Good afternoon and good morning. My name is Yi Kang. I come from the AP System, APSmart, DC side business union. My responsibilities mainly for the technical supporting and applications. So later on, anything related with the technical installations, just give me a call. Let me start my portion quickly. Let's talk about a little bit of IP systems. Just give a quick overview. A lot of them already know AP system was a global provider for the module level power electronics, and their mainly product will be on the AC side. Actually, is microinverter series. For the past 10 years, over 10 years, we have been already set up all the office and the business unit in the worldwide capabilities, including the USA, European, South America, in Asia, also some Australia. So we have two major manufacturers. One is located in south part of China, and another one was located in Taiwan. And we do have two R&D center, which one is located in California, another one located in South America, China, as an engineering team. We do surveys over right now is 130 right now other countries, and we also have a pretty much penetrate into local market, which means we have a local service team, a local sales team together to supporting our customer. Next, please. This old slide. Sorry about that. So let me introduce a little bit about our applications with the Fronius inverter. You can see from this picture, it's very easy understanding. So customer only need to purchase our receiver, which is RSD/S for PLC. That's one-on-one receiver, and you just install on individual module. Then you can immediately talking between the Fronius inverter, because we are both under Sunspec Alliance. So our complete protocol is the same. Next, please. Yeah, so let me introduce about our receiver. What's the structure and the features? From the picture, you guys see it's very easy in pricing. It's very simple. It's small, right? So when we design this device, we just wanted to fulfill the NEC standard for the rapid shutdown and the Sunspec protocol for the communication. So we only add those two functions into one small device. We will depends on the inverter monitor protocol, just like a Fronius have, so we can limit a lot of the noise or get better features. You can see we install both ends have two clips, so you can easily install on backside of your module anywhere as your design. It's very flexible, the small and the light, so we can working perfectly with the bifacial or corner J-box application as well. It's very reliable because we have our own designed ASIC chips instead. So basically, we integrate a lot of the components from the PCB board into small chips. Then we transfer our electronic reliability into the semiconductor, and we significantly increase our reliability in a lifetime. The last portion on this page was the powerful. It's very important here. I like to mention two parts. One, a lot of people ask me about what's the efficiency, but actually is a wrong term. It's not an optimizer. It's just like a switch. You can think about that. It's just turn on or off your module's power, which means it only have a power consumption. It's about 1 watt continually. And on the left side, I show in this slide, this is a certification testing real data. So you can see the blue line with 3 data point, which is from the 15 amp down to the top of the 15 amp, and it's 8 volt, 65 volt until the 80 volt. This line with the real testing data and be certified. What that means? This is very important chart because when you have vendor, your PV module vendor, and you want to get the knowledge or see if they're feasible for APSmart device, you can just compare with this chart. For instance, like you said, you have like 40-volt VOC for your PV module, and they have a 10 amp for the IC level. And this data point actually is below this 3 data line under. So which means under this area, any module parameter will be feasible. Keep in mind of that. That's a very good or easiest way to select your PV module vendor. Also, our technology, we have our IP technology is the lower minimum operating voltage, which is 7.7. And that is very low compared to the current device or competitor in the market. Normally they have 13, 14, even higher. What that means? So basically on a daily basis, in the early morning, our device will be turned on your PV module earlier, like 10 to 15 minutes. And during the nighttime or some draw, so our device will shut down your module later than 10 to 15 minutes. So on daily basis, you could get 20 up to 30 minutes extra energy compared to another, which means it's on daily basis, year by year for 25 years warranty. That's a lot of energy you can gain. Next, please. Stable. So you heard about the AFCI unwanted tripling issue for a while in our industry. And we did a study on that deeply with our partnership. And on the bottom, you can see there is a noise spectrum density comparison. And in the middle is the arcing noise spectrum density. On the right side, actually, we pick up some of the failed device. They do, if you look at it carefully, you can see there the spectrum density actually interfered with the arcing noise. So which means that's the root cause, which caused why the AFCI unwanted tripling is happening. And on the left side, we did a study on our own devices. So our noise density was way from arcing noise. So what that meaning is our device will never cause AFCI unwanted tripling issue. Compatibilities. Compatibility means we did add a bleed down circuit actually one of older devices, and we can survive over 18 amp right now for the reverse current. And that's very important because for some reason, whatever the installation or some mistake people always make in the systems, they will cause at a certain level have a reverse current, and that actually we can protect our customer and their PV modules as well. And this device actually is pretty well working with PV and the storage system. I do know some customer install that on the battery bank to control their safety. Next, please. Well, this is we call the RSD/D. That's a new product, next generation product is coming soon. Around by the end of Q2, early about Q3, that time frame. It's a dual device, which means a 2 module on 1 device. And what's the advantage I just briefly introduced right now? Of course, you can see it's more cost effective because it's 2 on 1 instead of 1 on 1. So you can get a better pricing on each individual device. More flexible. So our input was 0.5 meter, but output was 2.2 meters. And that will be much easier for the system designer or installer to adjust their orientations and the whole system design. The last point is most important is more powerful. because right now the PV module in the industry, they are the most manufacturers trying to adopt their large cell PV module into application, which means it's coming, and I don't know how far or how soon they're going to come in, but this device is ready for that kind of application already. So we have a 3 category or 3 level of this device, depends on the maximum input current level. 15 amp, 20 amp, and 25 amp. And on the right side, on bottom, there's the chart I listed here, give you a brief idea what's going to be the parameter what it looks like. And pay attention on this, the cable will be changed between the different current level. You can see it's a 12 AWG on the first 2 level, which is 15 and 20. But when it go up to 25, will be go to a 10W, which is the 6 millimeter squared. So pay attention on this. The reason we can get greater input current because we are developing the next generation of our Escobar chips to control, get better controllabilities and access to more product. Next, please. Right, let me quickly introduce our installation procedure. You can see the step 1 is just mounting your device on your module. So basically, you just connect with the PV tail, pigtails with the input. And at that moment, before they happen, out of the box, this device is not turned on. Its output, it will be a 0 volt. That's the number you need to look at to make sure anything with this device is good. Next, please. All right, so after this one will be connect your PV module. You can see how they connect with the corner J-box on the left picture and the original J-box on the top. It's very easy. The output, pay attention on this number. Output will be similar as the optimizer. It's a 0.6 volt up to 1 volt. That's regulated by the Sunspec Alliance. So always you look at this device output after you connect to your PV module. Next, please. Yeah, so when you install that into a string connected, what's the open air voltage? That's the very important number you need to look at next after you install the string. So basically, you just use the 0.6 up to 1 volt times how many devices you are in the string. For instance, you install the 10 module in one string, and you should be able to look at between 6 volt up to 10 volt, that range. As long as you're within that range, you're okay. Next, please. All right, so after the string already been installed or ready, some system required, before the combination, they required some IV curve or measurement the voltage, the system voltage after the turnaround. So we do have 2 very handy tool right now ready for the customer. One is called r.e.view/start kit. Another one called r.e.view. The start kit function is independently turn on your string without turn on the grid, which means if you want to do the IV curve or you want to see what's exactly the voltage come out from this string, you use this tool. And when you turn on that tool, they have a transmitter inside to generate the signal, and that is the string immediately active the modules. And you can see, you can measure on the output what's exactly the voltage from the DC side, or you use the IV curve analyzer to do the IV curve, or even you directly hook up with your Fronius inverter doing the self-check before you turn on the switch. Then you can actually do some IV curve independently with your inverter. The r.e.view+, they have 2 major functions. One is to sensing the PLC signal. And another one, they also can generate the signal, which means it's very handy tool to troubleshooting your device. So basically, they come with a cable connected to your device input and the signal transmit, turn on the device, and see the voltage output to make a judgment if this device is functional or fail. So yeah, keep in mind that, and if any question, just ask me. All right, so let me talk about an application quickly. When everything was on, you install into all the string into MPPT inside of a Fronius inverter, so everything should be ready, and the system should be under 30 volt requirement for NEC 2014. Next, please. Then you turn on your breaker, and the Fronius inverter turn on, and inverter already integrated, like Braulio told you, already integrated their desired transmitter inside. Then the transmitter turn on and start to transmit the PLC signals through the power line, get into each individual device on the module, and they turn on within 10 seconds. Next, please. Yep, so when you need a rapid shutdown, you just turn off your circuit breaker and your inverter will immediately turn on. And then inverter turn on, your transmitter turn off. And there's no more signal heartbeat transfer through the power line. So our device will sense that, then we shut down the module within 10 seconds. So basically, it's very simple procedure as is. Next, please. Yep, this introduced about the Fronius real-time monitoring protocol, which you should pay attention on this is for the voltage DC for each MPPT level. And that's the number you need monitoring regarding for the operation for the RSD, because if one RSD if happens to the field, they will show up on the voltage input level pretty much. So pay attention on this. Next, please. Yep, so we do been certified by the CSA for the UL 1741 Edition 2 tested, and also we have PVRSS with the most Symo, the new Symo, and some Primo Advanced the inverter. Totally we have on the list. You can ask me for the detail about the certifications. Next, please. Yep, that's pretty much from my side. And thank you for spending time with me learning APSmart. And thank you. Give back to Braulio.
Yi, thank you very much for your presentation. It's very valuable. I'm very appreciative of the work that you're doing. I look forward to do a lot of work with you going forward.
Thank you.
Okay, so in addition to optimizing the cost of the system, the Symo Advanced is also able of optimizing the performance. So I'm gonna have the last question of the presentation today. How important is module level optimization in commercial PV systems? I'm gonna rank that. I would like you to rank it from 1 to 5, 1 being not important at all to 5 being very important. Seems that we have a very engaged audience, so I'm just gonna give you a couple more seconds. So the majority of you said that it's somewhat important. So yes, it is definitely something to consider, which is why we have developed solutions towards it. So without further ado, I want to introduce Dynamic Peak Manager, which is shading can definitely affect the yield of a photovoltaic system. So depending on the intensity in the area that is in shadow, it can actually be detrimental to the total yield of the PV system. So we developed an intelligent system design that has efficient shade management. And so that will make it essential for the best possible operation of the shaded PV system. So we created Dynamic Peak Manager in order to bring out the best of your customers, even when there's shading. So this highly efficient MPP tracking algorithm detects any shade and optimizes the yield at the string level by scanning the entire IV curve and looking for the global maximum power point. And the best part of all is that you don't need additional components or sensitive components that are prone to fail in the roof in order to at the module level, and because it is already integrated into the inverter. And not only does this cost less because there are less components, it also keeps installation and service costs to a minimum. I wanna put this out here. We are confident that string inverters in the modern world outperform MLP. And so to add to my argument here, there's been a few studies conducted by academics and also by Fronius. One of them has been done by the University of Southern Denmark, which have shown that string inverters outperform traditional MLP in 95% of the systems. This has to do more with sophisticated shade mitigation algorithms in the modern string inverters, as explained with the dynamic peak manager, but also with the fact that DC optimizers are only able to recoup energy loss in the first place. So when there is no shade, the DC optimizers are actually just consuming energy. Even in shaded conditions, the recouping might not be enough to offset the energy consumption of the optimizers. Only in a very small number of systems where there is heavy shade, you can actually get an increase in energy output. And even then, you will have to look at the economics to see if that justifies the higher cost of MLP systems. And there's also been, as I said before, there's a study being done by Fronius that compared a Fronius system with a system with the DC optimizers. And it turns out that Fronius outperformed the system at any moment. So for details, if you want to see more about this document, I'd be happy to share that white paper with you. The Fronius MPP tracker is highly advanced, and the flexibility to not turn on the dynamic peak manager when it is not needed actually gives you the performance compared to having it on at all times. So what I mean by that is like dynamic peak manager is an optional feature that you can activate or deactivate as needed. It by default comes off, but if you're expecting that the site is going to be a lot of, there's going to be a lot of shading for it, you can actually turn that on yourself. And the last part, to ensure high system reliability throughout the lifetime of the system, our inverters are actually truly field serviceable, meaning that if they come with the option for parts replacement. So instead of replacing the entire inverter, you actually just repair the parts that are inside of it. And the repairs cost a lot less in terms of parts and labor because everything can be taken care of in one truck roll for lower operating expenditures. This helps you to reduce operating expenditures and improves the return on investment to meet performance expectations. As I was saying earlier on in order for you to determine if something's happening here with the inverters, the monitoring portal SolarWeb can alert you with messages. You can remotely diagnose and troubleshoot inverters that are on site. And if there is anything happening on the site, the monitoring system will prompt you to the one of our online support tools that allows you to prompt and troubleshoot this inverter. And if indeed there's a replacement to be done on the job site, we have a distributed network of Fronius certified installers called the Fronius Solution Partners, which are fully capable to do this type of servicing. They have access to the spare parts, and they're very well capable to handle any sort of Fronius inverter. So if you have any questions or if you're trying to learn more about this, feel free to reach out. I know we're cutting short in time right here, so I just want to summarize this. I want to summarize all the benefits that we talked about today. So what does a commercial solution look like? So to start off, if you have a basic string inverter system, just like the old days, you can go with that. So if your local code adoption does not require for rapid shutdown, you might just be fine with that. But if you live in a state where rapid shutdown is required, you add the APSmart device for easy and cost-effective code compliance. And as we believe that every system should be monitored, adding meaningful monitoring through SolarWeb is easy with this Fronius Smart solution, which has integrated Wi-Fi, and the setup is very easy to do. And to add even more value to the monitoring system, to further differentiate your proposal from the rest, and to gain the insight for future upselling, we highly recommend adding energy consumption monitoring. And if you run into one of those 15 or 20% of the systems that have shading, turn on Dynamic Peak Manager, but only then, as you don't unnecessarily want to add processing time into the inverter. And that's the beauty of it, so that you have the option to optimize a PV system. And to assist you with overcoming all challenges, we start with planning. And planning not only starts with the right inverter, but also with the right tools and best support to make the best choice. So taken all together, this is why the Symo Advanced is an excellent choice for commercial rooftop systems. And we will be happy to analyze your next project to calculate how much more optimized it would be using the Symo Advanced based on real numbers. And I just want to thank you very much for your time. I'm leaving you with my contact information as well as our tech support team. Our tech support team is well known for being very responsive, very knowledgeable, and they're just a few minutes away from calling as opposed to a few hours. So yeah, thank you very much. I will leave a few minutes for questions and remarks.
Yeah, thanks. We have exactly 2 minutes left, and we have 3 questions. So I'm gonna try to speed through these. I'm gonna start with the bottom because I know this was an easy one to answer. We've got, are APSmart products compatible with Fronius Primo inverters or Symo only?
So go ahead. If you want to take this on, you can. You can do that. But the short answer is it's only compatible with the Symo Advanced. The Fronius Primo is compatible with a different manufacturer that meets all the criteria we were talking about today in this presentation. If you have more questions on it, I'd be happy to take that offline with you.
Perfect. Thank you. The next question is, you mentioned something briefly about Symo inverters on a Delta system. My understanding is that Symos do not work with Delta as they require a neutral to operate. Is that incorrect?
The Symo Advanced 480 volt works on Y. Yes, you need the neutral for sensing, but you can do 2A, 240. I believe it's Delta. Yes, and it's with the high leg, so it's not. You don't utilize the neutral for sensing. You use it for as a high leg. Yeah.
Okay, thank you. Are you going to update your monitoring to PLC instead of Wi-Fi only?
Am I going to change the monitoring to PLC rather than Wi-Fi? So the Wi-Fi is what connects the inverter, the data manager to the internet, correct? So you can hardwire that via Cat5 cable, or you have the option to connect to the router via Wi-Fi. You could do both of them. But PLC, the communication that goes is the Sunspec communication that we were talking about. There's no monitoring being done between the APSmart and the Fronius Symo Advanced. That's just pure communication to or as a standby signal, which will in which the APSmart device does the shutdown when it's needed. So maybe Yi Kang, you can help me out on this one.
Sure. Yeah. Current version, we don't have a monitoring functionality for our device. We're just doing the follow the Sunspec communication protocol with the PLC as a heartbeat signal to control the device. We are actually working on that, some future product on the monitoring system, but I don't know too much about that yet. So yeah, I will keep you guys updates if I have any information from our design team.
Oh,
thanks. And so there's one last question, and this is about the litigation between Tigo and AP systems, and curious if that's going to affect what effect you foresee that having on this partnership.
Can you repeat your question?
So do you see any potential issues arising for the Fronius AP systems partnership with the Tigo litigation that's pending?
Yi Kang, can you take this one?
Yeah, sure, of course. I don't think so, because both Fronius and APSmart were under Sunspec Alliances. And for more about the Tigo AP systems integration issue, later on we have another webinar pretty soon from AP Systems, and our senior director from the marketing, Jason, will take over that portion publicly to answer the question from public. Just between the Fronius and the AP system, Fronius actually is supporting APSmart from the day one. And we are continually working together, keep our technology developing and working together pretty hard to fulfill all those applications into the market. So I don't think there will be any change from that at all. And also my personal opinion, because we exactly follow the Sunspec Alliance between the Tigo and the APSmart, actually AP systems is actually between Tigo and the Sunspec Alliances, which means my personal opinion is APSmart, if being stopped, will be the fall for everybody within the alliances. And also, after a whole year, we stepped out during the 2019 SPI. So in the whole year during the pandemic, actually our marketing developing pretty well. And we're working almost all the major distribution in the US market, including all the Fronius distributors to sell our product. And our market is growing and growing significantly, which means APSmart is not going away, whatever that happens on this lawsuit. That's my opinion.
Thank you so much. Well, that's we are over time, and just want to once again quickly say thank you to everyone for joining. Thank you to our panelists, and we really appreciate you being here, everyone.
Thank you
very much, Kate.
Take care,
Take care, everyone.